Welcome to a new lesson on a quick recap on map, reduce, and combiners. In this lesson, we would do a quick recap on the things we have learned till now. First one is the theory which we need to keep in mind while designing a solution. And in the next lesson, we'll do a recap on the code side what we have learned till now. First thing that we need to keep in mind when designing a map-reduce solution is to divide the solution into two phases, the map phase and the reduce phase. It is always to be remembered that the map would take input as a split which would have multiple records. For each record line, map function would be called and it would break the input record line into keys and values. We should smartly design our map logic so that at the reduce phase, when we look at the values from the same key, we should be able to reach to the objective which we wanted to bring about with the execution of the job. Next thing to be noted is that the input to reducer is in the form of key and list of values, and the result is in the form of pair of keys and values. Also, we should keep in mind that the map logic may be executed on a different machine and reduce on another machine on the network. This transfer of keys and values from all the map machines to the reducer machines is all taken care by Hadoop itself. We need not write any network programming to do it. We just need to smartly design the map logic and the reduce logic which turns the record into the keys and values pairs, and all the values of the same key are processed at the reduce phase to produce the result. The whole process of smartly transferring the data is all managed by Hadoop, and that is done through shuffle, sort and partition steps. We would learn in details about these steps later in the course. Then we learn about the combiners. The idea of combiners is simple. Its only objective is to reduce the map output so that there is less amount of map output to be transferred to reducer. In jobs which produce a large amount of data, this step is critical to the performance efficiencies of the job. If there is a lot of map output that needs to be transferred to the reduce machine, it is a good idea to design a combiner function which reduces the map output, and thus there is less amount of data to be transferred. Combiners as well have input in the form of keys and list of values and output in the form of key and value pair. Again, let us go through a simulation on how things are working in MapReduce, and there we would also peek into what we are going to learn in the later stages of this course. First of all, map would in most cases get the input split locally. Remember, Hadoop does its best to allocate maps tasks on the machines where data split is locally present. This won't be a possibility always, but Hadoop would try its best to do so. This split is processed by map logic to produce output result. Hadoop sorts and groups this map output by key, and programmer need not code anything for this. Now in case if there is a combiner function designed, then this map output would be fed into combiner function. Remember that a map output can go through the combiner multiple times, and so nature of operation done by combiner on the data would be an associative and commutative operation. Why map output is treated to combiner multiple times requires detailed understanding, which we would go through later in the course. This combiner produces the output result, and its idea is to reduce the size of the original map output. This map output has multiple partitions. Partitions are nothing but the portion of data that needs to go to the same reducer. These partitions are done by the partitioner function. We would as well learn in details about the partition function and how can we use it in our solution cases. These all partitioning and combining is done on the map machines locally. Like this map task, there are many map tasks that would be running across the network. These partitions are sent to their respective reducers by Hadoop, and again programmer need not code anything for this. On the reduce machine, Hadoop combines all the partitions and feeds in the merged file to the reducer, and reducer performs its logic to output the result. So I would again reiterate the things which we have covered till now in the course. First is that we need to only design the map logic and the reduce logic, and depending on the case, the combiner logic. The sorting of data and transfer of data is all taken care by Hadoop itself, and we need not worry about that. Second, it is not mandatory but would be great if we design combiner function which has the idea to reduce the map output so that there is less data to be sent across the network. Now the most important thing to note is that combiner function behaves just like reducers, as it has the input as keys and list of values, and just like reducer it outputs key and value pairs. So the combiners and reducers inherit the reducer class programmatically, but it is to be very well understood that they are logically very different. Although there can be many situations where we can reuse the reducer class as the combiner class, but it is not always true. As we can see in this diagram, the whole and sole objective of combiner is to reduce the amount of map output. And the objective of the reducer is to find the logical meaning behind the key and its values, which would help us to reach to the ultimate result. So their logical meaning and importance and stages at which they are executed and their design objectives are a lot different from each other and should never be confused with each other. Next, we learned that there is partitioning that happens because of partition function. Partitioning is the step in MapReduce to identify which data goes to which reducer. This same logic to identify the partition is applied across all map outputs, individually on the map machines. And these partitions are then sent across to their respective reducers. We are going to learn in details about partitioners in the coming lessons. The partitions are merged to a file and fed into reducer to produce the ultimate result. I hope by the end of this, you should be absolutely clear about the role and importance and the order of the phases map, combiner, partitioning, and reducer when executing a job. As well, you would have got an overall idea of the MapReduce framework in general. We are going to look in depth a few steps like partitioner later in the course. Please do remember the phases and in which orders they come about when a job is executed in MapReduce framework. This would help you better understand the phases and its importance to the solution. In the next lesson, let's just do a quick recap on code side of the things.